Good afternoon students, I am Kavita Monga, lecturer physics from Government Polytechnic College, Kuni Majra, Mohali. Today we will study about thermal expansion and different modes of transfer of heat. The topics which we will cover today are, we will define heat, temperature, thermal expansion, linear expansion, surface expansion, volume expansion. All these three are their types of thermal expansion. After that we will discuss what is transfer of heat, then the different modes of transfer of heat, namely conduction, convection and radiation. So today we will try to cover all these topics. So to start with, let's define what is thermal energy and temperature. So thermal energy, this is the total potential and kinetic energy associated with the random motion and arrangement of the particles of a material. सो कोई मटेरियल के जो पार्टिकल्स हैं, उसके मॉलिक्यूल्स हैं, उसमें उनकी टोटल पोटेंशियल एनर्जी और काइनेटिक एनर्जी, दैट कॉन्स्टिट्यूट्स द थर्मल एनर्जी. When a material is hot, it has more thermal energy than when it is cold. And temperature, we know this is the hotness or coldness of a material. So temperature is measure of hotness or coldness of a material. The quantity of thermal energy in a body affects its temperature. So thermal energy, it affects temperature. The same quantity of thermal energy in different bodies does not give each the same temperature. इसका मतलब ये है कि अगर two different bodies हैं, they have same thermal energy, it does not mean that they both will have same temperature. The ratio between temperature and thermal energy is different for different materials. So the temperature of a substance will increase if the average kinetic energy of its molecule is increased. So temperature, this is the average of kinetic energy of the particles. So when the average kinetic energy will increase, naturally the temperature will increase. If the average kinetic energy of the particle decreases, so does the temperature of the substance. सो जब एवरेज काइनेटिक एनर्जी कम होएगी तो टेम्परेचर कम हो जाएगा, जब वो बढ़ेगी तो टेम्परेचर बढ़ जाएगा. नाउ व्हाट इज हीट? नाउ हीट इज थर्मल एनर्जी दैट इज एब्जॉर्ब्ड, गिवन अप or transferred from one body to another body. So what is heat? What is definition of heat? Heat is thermal energy which is absorbed, given up or transferred from one body to another. Temperature is measure of a body's ability to give up heat or absorb heat from another body. So temperature is measure of coldness and hotness. The temperature of a body determines whether or not heat will be transferred to or from any nearby body. So all of us, we know that the heat transfer from body at high temperature to body at low temperature. So this is the temperature of a body which determines whether or not heat will be transferred to from any nearby body. Next, heat is a form of energy. We know heat is a form of energy. Heat is thermal energy in motion. Heat is used when the transfer of thermal energy from one body to another body at a different temperature is involved. So heat flow from high temperature to low temperature. Temperature is a physical quantity that is proportional to the average kinetic energy of translation of particles in matter. So temperature, it depends upon average kinetic energy of the particles. To measure the temperature of a body, you place the thermometer in contact with the body. So naturally जिसका हमने temperature लेना होता है, उसमें thermometer हम उसके contact में रखते हैं. So let's consider an example. If you want to know the temperature of a cup of hot coffee, you stick the thermometer in the coffee. As the two interact, the thermometer becomes hotter and the coffee cools off a little. So there is transfer of heat from coffee to thermometer. After the thermometer settles down to a steady value, you read the temperature. The system has reached a thermal equilibrium condition. So we say heat flow from high temperature to low temperature until the thermal equilibrium is achieved. So what is happening? A little amount of heat is flowing from coffee to thermometer till this thermal equilibrium condition is achieved. So in which the interaction between the thermometer and the coffee causes no further change in the system. So now what will happen? A temperature sense is often unreliable. The same quantity of thermal energy is different bodies does not give each the same temperature. So already we have discussed this point. If two bodies, if two substances, if two materials, they have same thermal energy, that does not mean that they will have same temperature. So this is very important point. On a cold winter day, so very interesting example, on a cold winter day, an iron railing seems much colder to the touch than a wooden fence post, even though both are at the same temperature. Winters में एक आयरन की रेलिंग और एक वुडन फेंस पोस्ट दोनों सेम क्यों नहीं फील होते? We touch, they both are at same temperature, but iron railing is much colder. So this error in perception results because the iron removes energy from our fingers more quickly than the wood does. So although they both are at same temperature, but there is difference. Why this difference is there? Because iron removes energy from our fingers more quickly than the wood does. So iron will appear colder as compared to the wooden fence. So another important point is what is triple point temperature? So triple point temperature, this is the single condition of temperature and pressure at which the solid, liquid and vapor phases of a substance can coexist in stable equilibrium. So that single condition of temperature and pressure where a substance can coexist in all the three phases, solid, liquid and vapor. Solid, liquid and vapor phases in contact and in equilibrium. Triple point temperature of water in the SI system is, this is 0 degree centigrade and this is equal to 273.16 Kelvin. So triple point temperature of water is 273.16 Kelvin. Another important concept is regarding temperature intervals. Originally two fixed points were used to define the standard temperature interval. दो fixed point हम लेते हैं जब हमने, when we have to say prepare a thermometer, we require two fixed points. So we say one is lower fixed point and one is upper fixed point. The steam point, that is 100 degrees centigrade, or the boiling point of water at standard atmospheric pressure. So one fixed point is steam point and the other one is ice point, that is 0 degree centigrade. It is melting point of ice when in equilibrium with water, saturated air at standard atmospheric pressure. So generally initially these two fixed points were taken, that was ice point and the steam point, and further the gap between these two, it was divided in equal intervals, and this was how thermometer scales were prepared. So now just compare, we will compare the three standard thermometer scales, that is Kelvin scale, Celsius and Fahrenheit temperature scale. So just quickly we will go through it. So just see here in this Kelvin scale, the lower point, this is 0 Kelvin and the upper point, this is 273.16 Kelvin. So upper point, this is triple point of water. So this is 273 degree Kelvin and this is absolute 0. This is not the lower point, this is absolute 0. The lower point, it will be that will be where that will be the freezing point of water. So triple point, this is the upper point in Kelvin scale. This is 273.16 Kelvin. In degree centigrade scale, this is 0.01 degree centigrade, and in Fahrenheit scale, this is 32.02 degree Fahrenheit. Similarly, the absolute 0 in Kelvin, it is 0 Kelvin. In centigrade scale, its value is minus 273.15 degree centigrade, and in Fahrenheit scale, its value is minus 459.67 degree Fahrenheit. So these are the formulas how we can convert value from one scale to another scale. First is, you have to change the value from Celsius to Kelvin. Celsius is centigrade. From centigrade to Kelvin, then what is the formula used? This is degree centigrade में जो value given है plus 273 degree. So the value जो आएगी that will be in Kelvin. Second is when you have to change the value of temperature from Kelvin to Celsius scale, then what to do? Then subtract minus 273 from Kelvin value. So we will get centigrade or Celsius value. So C, this is equal to K minus 273, and K, this is equal to C plus 273. The next one is when you have to change the value from centigrade to Fahrenheit. Then which formula we can use? We can use this formula. Temperature in Fahrenheit, this is given as 1.8 times temperature in centigrade plus 32 degree centigrade. And when you have to change the value from Fahrenheit to Celsius, we can use this formula, that temperature in centigrade or Celsius, this is equal to 5 upon 9 in bracket temperature in Fahrenheit minus 32 degree centigrade. So this was all about the temperature scales. We have quickly gone through this. We have discussed Kelvin, Celsius and Fahrenheit scales. The next is, what do you mean by absolute zero of temperature? So absolute zero of temperature, which is 0 Kelvin, at this what happens? The molecules of a substance at absolute zero have a minimum amount of kinetic energy known as 0 point energy. Molecule energy is at a minimum but not 0. So absolute zero is that temperature where molecules are known to have minimum amount of kinetic energy, but this is not 0. Now next, let's see what are the different units of heat. So quantities of heat must be measured by the effect they produce. No instrument directly measures the amount of thermal energy a body releases or absorbs. Calorie, this is quantity of heat required to raise the temperature of 1 gram of water by 1 degree centigrade or Celsius. So 1 calorie, this is equal to 4.186 joules. 1 food calorie is 1000 kilojoules, and this is equal to 4186 joules. So 1 food calorie, the food we consume, and we say so much calories we have consumed. So this 1 calorie, this stands for 4186 joules. So these are units, joules and calories and kilocalories, they are units to measure heat. Now next, let's start with what is thermal expansion of solids. So till now we have gone through different definitions. We know what is heat, what is temperature, and we also know different scales of temperature measurement. So now let's start, what do we mean by thermal expansion of solids? So solids expand when heated and contract when cool with a few exceptions. So solids को जब गर्म करेंगे, heat करेंगे, they expand and they contract when cool with a few exceptions. So there are numerous examples of this phenomena. We will discuss one by one. Heated solids increase or decrease in all dimensions. So this expansion means this increase can be in all dimensions. It can be in length, it can be in width, and it can be in thickness also. So when a solid is heated, the increase in thermal energy increases. So when a solid is heated, heat, what is heat? Heat is thermal energy. We've already studied this. So when a solid is heated, the increase in thermal energy increases the average distance between the atoms and molecules of the solid, and it expands. So the average distance between atoms and molecules, it increases on heating and they expand. So just see this figure, it will be more clear to you that what is happening. Thermal expansion can be explained on a molecular basis. Picture the interatomic forces in a solid as springs. So picture the interatomic forces at springs as shown in the picture. Each atom vibrates about its equilibrium position. Each atom is vibrating about its equilibrium position, and its motion is simple harmonic motion. So when the temperature increases, the amplitude and associated energy of the vibration also increases. So when we heat the substance, heat the material, then what happens? The amplitude and the energy of this vibration, it increases. So when it increases, they travel more distance, they can go to farther place. So in this process, the thermal expansion is there. The size of the object or the substance, it increases. So just see in this diagram, a rod is there, it is at 0 degree centigrade. When it is heated, 1 degree centigrade. So change in length इसकी increase हो गई है. So rod has twice the length. So when further temperature is increased, now expansion is 5 times as great. So 5 degree centigrade increase in temperature, so expansion is 10 times as great. Rod has twice the length, 5 degree centigrade increase in temperature. So this picture just show what do we mean by expansion. So when a rod is here, when we will heat it, then there will be increase in length. There will be a slight increase in length, say from 0 degree to 1 degree, and when from 0 to 5 degree, there will be greater increase in length. So this is what we mean by thermal expansions of solids. When the amplitude of vibration increases, the average distance between molecules also increases. As the atoms get further apart, every dimension increases, including the size of holes also. So this expansion is not only for length, area, or we say volume. So if a small hole is there and we heat it, then even the size of hole will also increase. So as the atoms get further apart, every dimension increases, including the sizes of holes also. Just see here, this is unheated. When we heat, then the hole, it gets expanded. So expanded hole is there. So size of the hole also increases on heating. So size of tiles also increases, and the size of hole also increases on heating. Now next, what is this coefficient of thermal expansion? The coefficient of thermal expansion describes how much a material expands for each change in temperature. Naturally, there are different types of material, and each material will exhibit different nature. That means if you heat two different material with same amount, the expansion will not be same. So what thing is different? That the thing is the coefficient of thermal expansion, it is different for different materials. So the coefficient of thermal expansion describes how much a material expands for each change in temperature. So examples are concrete bridges always have expansion joints. So bridges जब हम बनाते हैं expansion joints होते हैं, railway line जो बनाते हैं उसमें joints होते हैं. The amount of contraction or expansion is equal to the temperature change times the coefficient of thermal expansion. So कितना contraction या expansion होएगा, so this is equal to change in temperature times the coefficient of thermal expansion. So just see here, expansion joints are shown here. In summers when temperature increases, naturally expansion will be there, and we need space for that. Otherwise in roads also, in railway linings, in bridges, even in constructing buildings, we have to take care of expansion joints. So in winters what happens? Contraction is there, so space is there for that. अगर ये joint ना छोड़े जाए, space ना छोड़ी जाए, तो what will happen? The bridge will break. It will develop cracks and it will break. So now let's see the formula. What is formula for thermal expansion? So this is mathematical portion. So say this is a rod, its original length is L and it is at temperature T1. Say original temperature is T1 and the length of the rod is L. Then we heat it and its temperature increases to T2 and its length also increases. So say this increase in length is delta L. So original length is L, increase in length is delta L, original temperature is T1 and final temperature is T2. Then this change in length delta L upon original length L, this is given as alpha T2 minus T1. Now what is this alpha? This is coefficient of thermal expansion, and in this particular example, because it is increase in length, we say this is coefficient of linear expansion. Linear here stand for length. So delta L upon L is alpha T2 minus T1, where T2 minus T1 is change in temperature. Change in temperature, it can be increase in temperature, it can be decrease in temperature. Similarly, delta L change in length, it can be increase in length or it can be decrease in length. So delta L upon L is equal to alpha T2 minus T1. This is how we can find the value of alpha, or we can find what is the new length, or we can find what is the change in length. So this table, it shows thermal expansion, this coefficient of thermal expansion for different materials. So for steel it is 1.2 into 10 raised to power minus 5 per degree centigrade. For brass it is 1.8, for aluminium it is 2.4, glass it is 2. So this table, it gives you the value of coefficient of thermal expansion for different materials. So just see, in this table it is maximum for rubber it is 16. Now next, let's start with different type of expansions. There are 3 types of expansions. It can be linear, when the increase is in length, or it can be increase in area, or it can be increase in volume. So there are three types of thermal expansion. We will discuss one by one. We are starting here with linear expansion. So linear means increase in length. Coefficient of linear expansion alpha. So what is coefficient of linear expansion alpha? The change in length per unit of a solid when its temperature is changed 1 degree. So delta L, this is equal to alpha L into delta T, or we can write this delta T as T final minus T initial. So delta L is alpha L Tf minus Ti, T final minus T initial, where delta L is change in length. So this is final length minus initial length. L is original length, alpha is coefficient of linear expansion, Tf is final, and Ti is initial temperature. Or in other words, we can write the new length, this is equal to old length plus delta L. Delta L is increase or decrease in length. So new length, there is change in length, okay. So new length is equal to old length plus delta L. So this is linear expansion. Linear expansion means increase in length with rise in temperature. So this is an example. Diameter, if for problem that involve the contraction or expansion of two metals with different coefficients of expansion alpha. So now here we have two different metals. Say this is an aluminium ball, or outer metal is copper. If we will heat these two by same amount, that means T initial and T final are same, but the alpha will be different for both of these. कॉपर का अल्फा कुछ और होएगा, मीन्स उसकी एक्सपेंशन का रेट कुछ और है, एल्यूमिनियम की एक्सपेंशन का रेट कुछ और है. सो वी विल यूज़ दिस फार्मूला दैट अल्फा L1 into delta T1 plus L1. So this is for one metal, say this is for aluminium, this is equal to alpha L2 into delta T plus L2. So this will be for second metal. So we will in later on we will discuss an example on this problem, that is when there is linear expansion. Linear expansion means diameter, we also consider that diameter is also length. So diameter of this ball, it will also increase on heating. So this problem will be treated in the similar way as the problem of linear expansion. So second type of expansion is area expansion. So area expansion means increase in area. So when we heat an object, naturally if one length is increased, area is length into breadth, two sides, length into breadth, we say it is area. So naturally when we heat an object or substance or a solid, if its one length increases, naturally the second length will also increase, so area will also increase. So this coefficient of area expansion, we also call it as superficial expansion. So this is defined as coefficient of area expansion, the change in area per unit area per degree change in temperature. The change in area per unit area per degree change in temperature is called coefficient of area expansion or superficial expansion. The coefficient of area expansion for a solid is twice the coefficient of linear expansion. So this is very important point to remember, that coefficient of area expansion is twice the coefficient of linear expansion. So delta A, this is twice alpha A into delta T. A is area, delta T is change in temperature. So 2 times of alpha. What is alpha? Alpha is coefficient of linear expansion. So 2 alpha A into delta T What is delta T? This is T final minus T initial, or we can say new area is old area plus change in area. New area is old area plus delta A. The expansion of an area of a flat substance is derived from the linear expansion in both directions. So we already discussed that area means two directions, length into breadth. So this example of a hole is given here. Holes expands as well. So when you heat a hole, so this will expand and we can easily remove it from the hole. So delta is twice alpha A delta T. This is twice alpha A Tf minus Ti. T final minus final temperature minus initial temperature. Now the next type of expansion, this is volume expansion. That means when you will heat the material, now its volume will increase. Naturally अगर length increase हो रही है, breadth increase हो रही है, तो height भी increase होगी, तो there will be increase in volume also. So coefficient of volume expansion, this is defined as the change in volume per unit volume per degree change in temperature. The change in volume per unit volume per degree change in temperature. The coefficient of volume expansion for a solid is 3 times the coefficient of linear expansion. So now this is another point to remember, that coefficient of volume expansion is thrice that of coefficient of linear expansion. So delta V is thrice of alpha times V, this is original volume, and into delta V, that is change in temperature, that is rise in or fall in temperature. So 3 alpha V Tf minus Ti, Tf minus Ti, that is T final minus T initial. We can also write new volume, this is equal to old volume plus delta V. So coefficient of volume expansion for a solid is equal to 3 times of alpha. Coefficient of volume expansion is 3 times of alpha. If there is a hole in a solid body, अगर किसी बॉडी में होल है, if there is a hole in a solid body, the volume of the hole increases when the body expands. हम इसको हीट करेंगे, it will expand, so naturally इसका volume will increase, just as if the hole were a solid of the same material as the body. This remains true even if the hole becomes so large that the surrounding body is reduced to a thin shell. Thus, the volume enclosed by a thin-walled flask or thermometer bulb increases just as would a solid body of glass of the same size. So, thermal expansion of solid we are discussing. So, linear expansion we have already discussed. What is coefficient of linear expansion? Say this is original length L of a material. When you will heat it, it will expand. So this can happen. अगर हमने यहाँ पे space ना छोड़े अगर expansion के लिए, तो this can happen, this can break. So expansion and contraction of solid is considered in the design and construction of any structure that will undergo temperature changes. So we will have to take care of this expansion when we are designing some constructions. हमें जैसे example दिया मैंने, railway lines हैं, railway tracks, while laying railway tracks you will have to keep gap to allow this expansion and contraction. Allowance must also be made not only for changes in size due to expansion and contraction, but also for the different rates of expansion and contraction of different materials. So different material, they have different rate of expansion. We have already talked about this. So we must also take this thing in mind, that different materials, they expand by different rates. Now few examples, let us consider few examples of this thermal expansion. You can loosen a tight metal jar lid by holding it under a stream of hot water. So tight metal jar lid, एक metal की जो lid है, that is tight but it is made up of metal. We have to open it, we have to loosen it. What we can do, we can pass it under hot stream of hot water. Both the metal of the lid and the glass of the jar expand as the hot water adds energy to their atoms. With the added energy, the atoms can move a bit farther from each other than usual. But now what is happening? The expansion of metal is more as compared to that of glass. So expansion rate of expansion of metal is more than that of glass. So the lid expands more than the jar and it is loosened. So similarly, another example is there. Expansion slots are often placed in bridges to accommodate roadway expansion on hot days. This prevents buckling of the roadway. Driveways and sidewalks have expansion slots